Um, for cosine, yeah, it's -4/5, and it's -4 because.
There's just a cursor in the like thing somehow.
Oh yeah, sorry. So there's a -4 there. I'll move the cursor out of the way. There you go. Is that better?
Yes.
Okay, so yeah, so that's how we would identify these 6 trig identities, all right, or trig functions for something in standard position angle. Got to use that Pythagorean theorem to find the third side first, and then we can go ahead and do our y/r, x/r, and again, the signs are just determined. This negative sign was just determined basically because I'm on the negative x-axis, and the 3 was positive because I was on the positive y-axis. So I was in quadrant 2 of the 4 quadrants, and that's how I determined the signs there. Okay. The circle that we're going to deal with a lot is called the unit circle. And the unit circle, which we talked about this last year as well, and we've probably talked about in AGS 3, so we've seen this a couple times now. X squared plus y squared equals 1. It's going to have a center at 0, 0, just like all the others, but it's going to have a radius of 1. Okay. And then what happens on the unit circle is when you're doing sine, you're going to end up with y/r, and cosine is going to be x/r because r is the radius. But in this case, the radius is just 1. So it's really y/1, and cosine is x/1. So the sine is really just the y value of the ordered pair, and the cosine is just the x value of the ordered pair. So the values of x and y are simply the x coordinate and the y coordinate respectively of the point where the terminal side of theta intersects the unit circle. That's what this whole sentence means here. Basically, if I give you a radius of 1 on a circle, then you always know your sine is going to be just the y value of the point, and your cosine is going to be just the x value of the point. All right. And then we have what's called quadrantal angles. And those are trig values that are multiples of 90 degrees. All right. So anything that is a multiple of 90 degrees. So for example, 90 degrees would be a quadrantal angle. 180, -450. They could be positive, they could be negative. Like -360 is a quadrantal angle. That's another possible example. 270 degrees is a quadrantal angle. That could happen as well. Okay. So those are kind of the ideas there for quadrantal angles. And the reason we will talk about these types of angles specifically is because those are the only angles where I can't form a triangle with the x-axis. So that's what example 2 is going to be looking at here. So for example 2, it says use the unit circle to evaluate the 6 trig functions. So 6 trig functions, we'll go ahead and set that up right now. Sine theta and cosecant of theta. And then we're going to do cosine of theta and secant of theta, 1 co. And then the last one, tangent of theta and cotangent of theta. But now it says use the unit circle to evaluate 6 trigonometric functions of theta equals 270 degrees. Because it's a positive 270 degrees, I start right here at the positive x-axis, and I rotate 270 degrees down to here. There's my 270 degree angle. And now, if I were to try and draw a triangle back to the x-axis, I would just draw it straight back, unfortunately. So it doesn't really form a triangle, it's just a vertical line. That's kind of annoying. But the trick here is that we said use the unit circle. So I know what the radius is. The radius is going to be 1. So if I were drawing this entire, let's draw a circle here. Not my finest circle, but there we go. Looks like the Death Star before it got completed. Okay. But I've got this point down here. The radius is 1, so how far... This point is 0 units on the x-axis. How far has it gone on the y-axis down to this point down here? What's the y value going to be there? Any guesses? It's actually going to be -1. And that's just because the radius is 1. So this is going to be a distance of 1 from the center, but it's in a negative y direction. So the point is 0, -1. And what that does is I know what the radius is, and I know what the x and y values are, so I can still set up my 6 trig functions. That's the idea with this particular problem. So sine is -1 over +1, because the radius is 1, or just -1. Cosecant would be +1 over -1, which is also -1. So I can still evaluate my 6 trig functions. I would just be saying for this one, that's what these values would be. Okay. For cosine, its x value is 0, and the radius is 1. 0 divided by 1 is just 0. The reciprocal would be 1 divided by 0. The radius is 1. The x value is 0. And that is undefined. We cannot have a denominator. We cannot have a denominator 0. Sorry, was there a question?
Yeah, sorry. I was just wondering how you got the -1 again. Is it because the angle was 270? Or is that like something that's like for every unit circle problem, the y value will also be 1 or -1?
No, it is because the angle is 270. So what happens is the radius is definitely 1, the radius of the circle. So, for example, if it was a 90-degree angle, then this point would be 0, +1. If it was a 180-degree angle, this point would be -1, 0. So the x value would be -1, but the y value would be 0, just because it's on the ordered pair. The radius is always going to be a +1, but the point where this falls is -1 right here. And then if it was a 360-degree circle, it would be 1, 0, because I'm a distance of 1 from the center, but I'm in a positive x direction. Or
Okay.
Does that make a little more sense?
Yeah, that makes so much sense. Thank you.
Okay, of course, no problem. It's a good question. These unit circles are the toughest ones in my opinion, because you can't really visualize the triangle. Tangent, last one, y over x, -1 over 0. Well, that's going to be undefined. And then the other one was x over y, 0 over -1, and that's just going to be 0. And notice I don't say equals undefined, I just say undefined. Okay, but so tangent would be undefined for this problem, and secant would be undefined for this problem, but the other trig functions are either going to be -1 or 0 after we set up those ratios. All right, you guys have 4 problems here. One of them is going to be using the unit circle. The other 3 are going to be triangle method. Remember, always draw your triangle back to the x-axis. X-axis, never to the y-axis. That's the one mistake students can make. That could be bad. So try these 4 problems out now. Set up your 6 trig functions for each of them. So for problem 3, the radius should come out to 13 when we run our calculations. So the sine is -12/13. That means the cosecant of theta is going to be 13 over -12. Cosine is going to be -5 over 13. So it means secant is going to be 13 over -5. And I did not do a great job of leaving us a lot of room here. The last one, tangent, is going to be 12/5, just because they're both negative. And that means cotangent is going to be 5/12. Okay. So I did not leave a lot of room on that one. I apologize for that. the very last one, it's a unit circle, and we're evaluating theta equals 180 degrees. So we're using this point over here, -1 comma 0. And that should hopefully help us set up our 6 trig functions then. So we know the radius is going to be 1. Oops. This side's going to be tangent. And this is going to be cotangent. Going too fast. Cotangent of theta equals. Okay. So radius is 1, so the sine is going to be 0 over 1, or just 0. Cosecant then would be 1 over 0, which is undefined. Cosine is -1 over 1, so that's just -1. And that means secant is going to be 1 over -1, which is also -1. Tangent, 0 over -1, so that's just going to be 0. And cotangent's -1 over 0, that's going to be undefined.
Is there an abbreviation we can use for that?
Undefined? Yeah, I don't know. You can use UND, that's fine. UND abbreviated. All right. But yeah, undefined. Okay. So that's the idea for the unit circle problem. Just identifying the point -1 comma 0. That's the half circle. And then we can go ahead and set up our trig functions based on that. All right. Last thing to talk about today, these reference angle relationships. So the reference angle, I already hinted at it kind of. It's just the theta prime. It's the angle that forms the triangle back to the closest x-axis. That's the reference angle. All right, so that's always going to be your reference angle, the angle that goes back to the x-axis in the shortest amount of time. All right, so the reference angle for each of these, we just need to find what's the angle that gets us back to the x-axis. So if we did like a 300-degree angle for example 1, we start on the positive x-axis. 300 degrees means we're going to go past 90, past 180, past 270, and we're going to end up over here somewhere. So that was 300 degrees. So we want to figure out, well, how much further do we have to go to get our reference angle? We would have to go another 60 degrees. That's what this would be. So in quadrant 4, that's what this example is. We would just do 360 minus theta. That's how we'd find our reference angle. Okay. In quadrant 2, it wouldn't be 360, it would actually be 180 minus theta, because we would just say 180 minus whatever this angle was, and that's going to give us our reference angle. In quadrant 3, it's going to be theta minus 180, because if we went like 220 degrees, we would just do 220 minus 180, and we'd get 40 degrees for our reference angle. That's kind of how those things work. Okay. That's how we would find our reference angles to get our theta prime. And this last one is -130 degrees here. So this is where we would go the opposite direction because it's a negative sign. So we go past -90. -130 is going to be somewhere over here. Reference angle is going to be right here, theta prime. So for this one, it's in quadrant 3, so we would do, or in this case, we could do like the quadrant 2 opposite. But we want to say we got to get to -180 degrees. So theta prime is going to be 50 degrees to get us there. All right, that might be the easiest way to think about it. Just how far away are we from the x-axis? We are 50 degrees away. Sometimes they can get a little tricky with those negative reference angles. All right, but that'd be the exact same thing as saying if we went in a positive direction, instead of going -130, we went positive 230 to get to that exact same spot. And then we could say 230 minus 180, and we get 50. All right, something weird like that. Okay, that's the idea for reference angles So just finding that small angle that's going to connect us to the, all right, to each value. Okay. The last, I guess this is actually the last thing we're doing is the evaluating trig functions. And this is all about being able to do this like without it using a calculator, which you would not be expected to do this on the IB exam. But if you're able to do it without a calculator, then you're in really good shape for the IB exam. It's showing that you really understand what's happening. It's kind of putting everything that we've talked about today together. So the first thing we want to do, step 1, find the reference angle. All right. And we already know what the values are, like the x and y values, if they're positive or negative, which quadrant they're in. So that's going to help us. And we're going to evaluate the trig function for the reference angle. And then the third part is it says determine the sign for the trig function. And what happens is, for example, if I were to say, let's do theta equals 130 degrees, right? And I said, let's find sine of 130. So if I were just to put sine of 130, actually, let's do, let's do cosine of 130 instead. We'll do cosine of 130 degrees. So we're already rolling with this. So if I were to put cosine of 130 degrees in my calculator, go ahead and do that now if you have your calculator available. And you're going to get a negative number. I know it's going to be a negative number. I just don't know what the number is going to be. But there's our theta. So what do we end up getting for cosine of 130?
It's negative 0.642.
Negative 0.642. Thank you very much. So now if we were doing our theta prime, all right, that's going to be a 50-degree reference angle. So go ahead and put cosine of 50 in your calculator, and I can tell you right now it's going to be a positive 0.642. But go ahead and put it in your calculator and you'll see that. Okay, but you'll see that one of them is negative, one of them is positive. But they're the exact same number besides that. It's just one's negative, one's positive. And what's happening here is we're going, which is why I changed the value, because we were going in a negative x direction. So when we're setting up the cosine function, it's going to be negative x over y, or over r. That's how we'd set up the cosine. So that's why it's the cosine of 50, because cosine of 50 thinks about it like, oh, if I'm in quadrant 1, I'm in a positive x direction over this. That's why it says over here, determine the sign. So honestly, I don't really worry about these rules too much as long as I understand which quadrant I'm in and I know whether the x value is negative or whether the y value is negative, then I don't need to worry about these steps too much. But basically, what's going to happen in quadrant 1, all right, sine is going to be positive because that's a positive y value and a positive r value. Cosine is also going to be positive, again, because it's a positive x value and a positive r value. Tangent is going to be positive because you have a y divided by x when you're setting up the tangent equation. In quadrant 2, this is why I changed from sine to cosine, because sine's still going to be positive because I'm still going in the positive y-axis here. Cosine is going to be negative in quadrant 2 because I'm on a negative x-axis. And tangent is also going to be negative because I have a positive y divided by a negative x. In quadrant 3, sine is going to be negative. My cosine function is going to be negative no matter what because I have a negative y and negative x. Tangent is actually going to be positive in quadrant 3. And then in quadrant 4, sine is going to be negative. Cosine is going to be positive. And tangent is going to be negative. All right. That's how we would determine the signs, like the literal sign, positive or negative, of each function in each quadrant. All right. Just based on, again, I'm sorry, say that again?
What's the rule for the 90-degree one? So like you have like the 180 minus theta equals theta prime. What is the rule for quadrant 1?
Okay. Oh, so the rule for quadrant 1 is they're always going to be positive in quadrant 1. Because in quadrant 1, here, let me show you real quick.
Theta.
So in quadrant 1, what happens is, like, let's say I want to do theta equals 30 degrees.
Can you move to the right a little bit?
Sure. So in quadrant 1, I want to do 30 degrees, and it's just going to be a 30-degree angle. That's also our reference angle. It's the exact same. So quadrant 1, the reference angle is always the exact same as the angle given. That's the rule for quadrant 1, if that makes sense. Okay. Hopefully it does make a little bit of sense. Okay. So what happens in these types of problems, when it says evaluate the function without using a calculator, what we're going to do is we're going to use the unit circle for these types of problems. So we're going to imagine a radius of 1. And what we do is we do tangent of negative 240 degrees. So we're going to start by going negative 180, and then a little past that, we're going to end up over here somewhere. So there's theta of negative 240 degrees. So we ask, how far past 180 did we go? That's going to be our reference angle. It's going to be 60 degrees. Okay. That's how we'd kind of set this up. And the reason we're doing the reference angle here is because when I find the reference angle is always going to be like a 30, a 45, or a 60, theoretically. So that way I can evaluate without using a trig function. That's what these problems are doing here, these A and B. Now, I didn't give you guys the unit circle before we started.
Wait, so what number are you subtracting it from?
For this one right here?
Mm-hmm. Is it 270?
No, it's actually 180. It's 240 minus 180. And I'm going to go 60 degrees past that. Yeah. Okay. So it's always going to be 180 or 360 that we're subtracting from. Now, I didn't give you guys the unit circle, so I apologize for that. But unit circle is just a quick Google away. Basically, you want to know in quadrant 1 for the unit circle, you want to know what a 30-degree angle looks like with the radius of 1. And the 30-degree angle with the radius of 1 is going to be root 3 over 2, comma 1/2. The 45-degree angle is going to be root 2 over 2, root 2 over 2. And the 60-degree angle is going to be 1/2, comma root 3 over 2. Okay, so we just switched the x and y values from the 30-degree angle. If we know those values, we could evaluate any one of these trig functions. And what that means is, what I'm doing here is I'm saying, hey, this is a 60-degree angle, so I want to use these numbers here for tangent. But I'm in quadrant 2, so my x value is going to be negative, so it's going to be a negative 1/2, and the y value is going to be positive, root 3 over 2. Okay, that's how I would use those values in the unit circle. We kind of skipped some steps there because I did forget to add the unit circle to today's lesson. I was worried about time, and I threw this together pretty quickly, and I realized that I did not put the unit circle on there, so sorry about that. So that's what's going on with this part, with these evaluate without using a calculator. But again, we did these last year, so hopefully this is familiar for us. This is just a little bit of review, what we're doing on these problems. And we did this 2 years ago in AGS 3. So again, hopefully this is a review for us over the last couple of years. So now tangent is y over x. And if I'm doing tangent of negative 240 degrees, the y is positive, root 3 over 2, over negative 1/2. And then I would just simplify because it's a fraction divided by another fraction. I can multiply by the reciprocal. instead. And the 2's will just go away, and I'm going to be left with negative square root 3. So turns out tangent of negative 240 is just negative square root 3 when it's all simplified. All right, so that's what happens with example A there. Okay. Example B is cosecant of 420. So I'm going to have to go a full 360 degrees around. I'm going to say, how much past 360 am I going to go? I'm going to go another 60 degrees. So I'm going to be in quadrant 1. So my reference angle is 60 degrees. Okay? Cosecant is the reciprocal of sine of the sine function. So now with the sine function, I'm going 60 degrees. I'm going to use those same values where it was the x was 1/2, the y was root 3 over 2. So sine of 420 degrees is y over r. Thankfully, the r is just 1. So it's just root 3 over 2. Cosecant of 420 degrees means I flip that over. 2 over root 3. And that's how I would evaluate this trig function here. Okay. Kind of weird, those types of problems. Like I said, I just kind of jumped into the unit circle there without giving us a really good explanation of it. But that's review from last year. We did some of these evaluating without a calculator last year, and we did these 2 years ago as well. All right. Last 4 problems here, it just says sketch an angle and then find its reference angle. And then problem 9 is evaluate cosine of negative 210 without using a calculator. So you can try one of those problems out without using a calculator. We got about 8 minutes left. See if you can get these 5 problems done in that 8 minutes. Oh, and for the assignment tonight, I will be posting an answer key. It is not a book assignment. It's just some practice problems here. So I'll post an answer key for the assignment tonight. I haven't done it yet, but I will get that done for you guys.